everyone, welcome back to the Road Reverence. The Russian Project 23,000 inches Shtorm stands as one of the most ambitious naval projects ever conceived by Russia, designed to be a future supercarrier capable of rivaling the most advanced aircraft carriers in the world. It is envisioned not simply as a ship, but as a floating fortress and a mobile airbase that could extend Russia's naval influence far beyond its home waters. Measuring approximately 330 meters in length and displacing between 90,000 to 100,000 tons, this massive vessel is designed with a sleek, stealth-inspired hull and superstructure intended to reduce radar cross-section. Its profile is dominated by a hybrid ski jump and catapult launch system, allowing flexibility in aircraft operations and enabling the launch of both heavy and light aircraft with greater efficiency. The overall exterior design reflects a combination of brute strength and advanced engineering, with a broad, reinforced flight deck that can handle extreme operational demands while maintaining a modern aesthetic. The flight deck itself is a marvel of naval architecture, stretching long enough to accommodate dual runways and parallel takeoff operations. The island superstructure, positioned slightly to the starboard side, is compact yet packed with advanced radar domes, phased array sensors, and communication arrays, all seamlessly integrated to maintain aerodynamic flow and reduce drag. The ship's massive elevators connect the flight deck to spacious aircraft hangars below, allowing for rapid deployment and storage of its air wing. Every visible element of the exterior emphasizes functionality and readiness, from its reinforced hull plating designed for ice navigation to the integrated close-in defense turrets subtly mounted along its flanks. Its towering presence on the horizon would be as much a psychological weapon as a physical one, projecting dominance across any maritime theater. Inside the Project 23,000 inches Shtorm, the focus is on efficiency, automation, and crew comfort. Despite its massive size, the ship is designed to operate with an optimized crew of around 4,000 to 4,500 personnel, supported by advanced automated systems to reduce manual workload. The interior layout is highly compartmentalized for damage control and survivability. Crew quarters are more spacious compared to older Russian carriers, with modern living facilities, recreation areas, and climate control systems designed for extended deployments. Operational areas like the Combat Information Center are equipped with next-generation digital battle management systems, while hangar bays are fitted with automated aircraft handling equipment to speed up sortie generation. Performance-wise, the Shtorm is envisioned to be powered by dual nuclear reactors, providing virtually unlimited range and allowing sustained operations at sea for months without refueling. These reactors would generate not only propulsion but also the massive electrical power required for advanced radar systems, catapult launches, and electronic warfare suites. Its top speed is expected to reach around 30 knots, impressive for a vessel of this size, while its endurance would be limited more by food and supplies than by fuel. The carrier is designed to operate in a wide range of climates, from the icy waters of the Arctic to tropical seas, thanks to its reinforced hull and robust environmental systems. Stability is ensured through advanced ballast systems in a hull shape optimized for reduced drag and improved hydrodynamics, allowing for smoother flight operations even in rough seas. The Project 23,000 inches Shtorm would boast one of the most formidable safety and defense systems ever installed on a Russian surface vessel. Air defense would be handled by the Polyment Redute surface-to-air missile system, providing layered protection against incoming aircraft and missiles. For close-in defense, multiple CIWS installations would automatically engage fast-moving threats such as sea-skimming missiles or drones. The carrier would also integrate advanced electronic warfare systems capable of jamming enemy radar, communications, and missile guidance systems, creating a powerful defensive shield. Compartmentalized hull sections, double hull construction, and advanced firefighting systems would enhance survivability in combat. The nuclear reactors would be housed in heavily armored, isolated compartments to minimize the risk of catastrophic damage in the event of an attack. One of the unique selling points of the Shtorm is its massive air wing capacity. Designed to carry 90 to 100 aircraft, it would be able to deploy a combination of fighters, strike aircraft, AWACS planes, helicopters, and UAVs. Likely candidates include naval versions of the Su-57 stealth fighter, MiG-29K, Su-33, Yak-44 AWACS, Ka-31 early warning helicopters, and various unmanned aerial vehicles for reconnaissance and strike missions. The hybrid launch system, combining ski jump ramps and electromagnetic catapults, would allow for rapid, flexible launch and recovery cycles, reducing bottlenecks during high-intensity operations. Additionally, the ship's integration of hypersonic missile systems like the Zircon would give it offensive capabilities far beyond the role of a traditional carrier, making it a hybrid between a floating airbase and a missile platform. Another defining feature of the Shtorm is its adaptability for future warfare. The vessel's design incorporates modular weapon bays, easily upgradable sensor systems, and the capacity to integrate unmanned combat vehicles both in the air and on the sea surface. With Russia's increasing emphasis on Arctic navigation, the carrier's ice-capable hull allows it to operate in polar regions where few other supercarriers can safely venture. The stealthy superstructure design and radar-absorbing materials would reduce detectability, giving it a better chance of surviving in contested environments where enemy surveillance and targeting systems are constantly evolving. Pricing for such a vessel is difficult to determine precisely because it remains in the conceptual and design stage, but estimates suggest a cost of around $5 to $7 billion United States dollars, depending on technological integration and construction pace. This would represent one of the largest single defense investments in Russian naval history. The final cost would also depend heavily on whether Russia builds one or multiple units, as economies of scale could reduce the per-ship price. While expensive, the strategic return in terms of global reach and deterrence value would be immense. In conclusion, the Russian Project 23,000 inches Shtorm is not just a ship, it is a statement of intent. Its design merges the lessons of past Soviet and Russian carriers with modern naval warfare requirements, blending raw power with technological sophistication. If constructed, it would provide Russia with a carrier on par with, or potentially superior to, some Western equivalents in certain areas, especially in missile armament and adaptability. While the challenges of funding, shipbuilding capacity, and technological integration remain significant, the concept alone demonstrates Russia's desire to maintain a true blue water navy capable of projecting power far from its shores. The Shtorm represents a vision of naval dominance, combining stealth, endurance, flexibility, and sheer size into one of the most formidable warship concepts of the 21st century.